In our series about the human brain, we've told you about what goes on in our heads when we shop, when we eat. But what about when we're not so active? New discoveries are showing that the brain in a resting state isn't as dormant as previously thought. And as Kelly Crow tells us, this dark side of the brain may be the key to healing mental trauma.
Look, no hands. Teresa Kinney keeps this computer rocket flying using nothing but her brain waves.
And my focus is on keeping this thing going.
She's not sure how she's doing it.
I have no idea. I just focus all my eye energy on this.
So you're flying a spaceship with your brain without touching a single thing?
Yes.
And how does that feel? You said you feel tired.
I feel exhausted.
Remember, you're in control and you can stop this at any time.
Okay.
Okay?
Researcher Ruth Lanius is trying this novel therapy to help Teresa recover from childhood trauma.
I was gang raped repeatedly between the ages of 11 and 14.
A horrific experience that triggered years of suicidal, self-destructive behavior that doctors couldn't treat and couldn't even name.
Oh, what didn't they call it? I had bipolar disorder, schizoaffective disorder, depressive disorder, schizotypal personality, borderline personality. You name it, I was called it. I think my last diagnosis before Ruth was schizoaffective. All I knew that none of them were right.
And now research is suggesting that extreme childhood trauma caused biological damage to Teresa Kinney's brain, severing links in a mysterious neural network that neuroscientists are only beginning to understand.
So now we're starting to see some brain, so this is gray matter here and white matter.
To travel inside a living brain is a journey that was unimaginable a few decades ago.
The different parts of the brain have different functions.
In the early days of neuroscience, researchers had only two choices: dissect an autopsied brain to learn the basic structures, or remove the skull, expose the brain, and poke at it, asking patients to respond.
You feel something then?
They did that only when they had the brain open for other reasons. It was a chance to learn more.
Slow tonic contraction.
It was a standard part of surgery for epilepsy, so surgeons could avoid damaging a critical area of the brain. But it was far too invasive for curious brain browsing.
The brain scanner provides much more precise information for a neurosurgeon.
Technology gradually allowed scientists to first X-ray the brain and later use magnetic resonance imaging to watch what happened when people were told to think specific thoughts. The machines measure the blood oxygen flow, so where it lights up, that's where the thought happened in the brain. And where there was no thought, scientists assumed the brain was essentially idle.
We were so focused on what the brain was doing when people engaged in certain cognitive activities, right, such as recalling memories, or thinking about the future, or looking at different faces with different emotional expressions. Very little thought was given to what happens in the brain when it's at rest.
Until fluctuations in neural energy led to an accidental discovery that something important was going on in those dark areas of the brain.
Rest in that position.
Now researchers are busy investigating this previously unrecognized neural network that seems to kick in when conscious thought stops.
Was there skepticism about this discovery in the beginning?
Oh, huge. It was such a novel idea.
For neuroscientists, it's a mysterious dark side of the brain.
It does a lot of important work which we don't know. And as you said, in the dark. Because we have no idea in the moment why there is this resting state activity and what it does really do and what the purpose of it is. These are exactly the regions where there is very high resting state activity.
Neuroscientist George Northoff says this resting state takes much more energy than conscious thought.
It's always there and it still consumes 20% of your body's energy. So why they held so much energy for such a small organ up there? Yeah, we don't know. And when you do certain tasks, that intrinsic activity level only changes by 2%. So, and we have no idea.
So this resting state network may be the conductor of all other networks in the brain. That would consume a lot of energy.
It could be running the whole brain.
It could be running the whole show, right? And then, you know, sort of set the brain up for what network needs to become activated depending on whatever scenario the person is in. And so if we think about it as a conductor of the brain, that makes sense.
Some researchers believe the brain's resting state might hold the key to the elusive sense of self, our inner voice, our unique experience of what it means to be ourselves. And when this system isn't working, when it's hard to switch easily in and out of this intrinsic network, researchers believe this could lead to depression and other mental illness.
When you're in depression, you just focus upon yourself. You're completely detached and dissociated from the environment. Your focus is just on yourself and on your body, and you feel pain and your own emotions and guilt, but you don't connect to the other person anymore, so they feel disconnected. And we assume, and there is pretty solid evidence, that that is related to these abnormalities in resting state.
The official name for this resting state is default mode network, and Ruth Lanius has discovered that it seems to be damaged in patients who suffered childhood trauma.
So that's the default mode network. That's what it looks like.
Yeah, in healthy controls, and a lot of studies have shown that. And so if we move to the bottom panel, we look at patients with post-traumatic stress disorder related to childhood trauma. And you don't have to be an expert in neuroimaging to see that this is very different.
That's what it looks like in a child.
Yeah, this comes close to what a default mode network looks like in children ages 7 to 9.
So this is somewhat looks like it's just not mature.
Yeah.
Which means to help patients like Teresa Kinney, doctors might need to repair those connections.
So it's not just behavioral adaptations then that you would need to fix. It's not just getting people to act in a certain way or do a certain series of things. It's actually changing the network in the brain to put it back into a healthy state.
Absolutely, yeah.
For Teresa, it's all a little odd, controlling a computer using brain waves she can't even feel.
It is a little freaky to say the least, but it's been very successful for me. I've seen a lot of changes in the last year since I first started this.
And how has that changed your life?
It's made me much more functional.
Whatever is going on inside that mysterious neural darkness still isn't clear even to researchers, but it's one of neuroscience's most compelling questions. Kelly Crow, CBC News, London, Ontario.